Thank you very much. I present to you Time and Architecture Enduring by Design. Architecture is definitely not just forms or shapes. Architecture is also time made tangible. From beautiful 500-year-old Italian Palladian villas to prairie houses in the US from the 20th century to the most recent Malagueira houses in Portugal designed by Siza, architecture is more than just what we see. It's almost like a time capsule that we can walk into. It encapsulates culture, beliefs, stories, history. So let's revisit a little bit of the past and make sure that we learn some lessons for the future. So let's look at this drawing. This is a 500-year-old drawing designed by Palladio, one of the most renowned architects, Italian architect from the 1500s. This is the church of San Giorgio Maggiore, standing powerfully in front of the Grand Canal in Venice, designed 500 years ago with classic features, as you can see, symmetric, precise, accurate, beautiful. Fast forward 200 years, and this is a painting by the renowned Italian painter Canaletto. He painted this in the 1700s, and what you see is the same church, San Giorgio Maggiore, standing exactly as planned 200 years before by Palladio. The same facade, the same domes, the same church bell tower, everything, even the reflection on the canal, is precise. It's like time has been crystallized in this work of architecture. Then, look at it now. It stands exactly as it was 500 years ago. The design endured, the facades endured, the church tower endured, everything as planned by Palladio 500 years ago. It's all there, all crystallized. It has survived 2 world wars, floods, earthquakes. It has endured in design. Then fast forward to the 20th century. So this beautiful drawing was designed by great American architect Lloyd Wright. A very radical design. This specific building is a residential building, a holiday house, commissioned by Mr. Farnsworth directly to Mr. Wright. Mr. Wright used this exactly same drawing, which is now exhibited at the MoMA in New York, to pitch his radical idea of designing on top of a waterfall. How radical, how crazy. Well, radical now, still radical here. It's so radical that the structural solution was never tested before. Reinforced concrete terraces suspended above a waterfall. Really, really powerful. The story tells that the laborers, the workers, after constructing this concrete marvel, were very scared, actually terrified, of removing the formwork, fearing that the whole building would collapse on top of them. The story says, and probably an urban myth, that Mr. Wright removed it himself, proving that his design, his daring design, was not only a dream, but exactly feasible. Then look at it. 80 years later, still stands powerfully on top of this waterfall. Everything around it changes. The foliage, the vegetation, the water continues falling in the falling water. However, the design is intemporal, is everlasting. It has lasted for all this time. Then, similarly, let's look at the work of Siza. Siza, great Pritzker Prize architect who designed in the 70s, in the late 70s, a low-income community in the southern part of Portugal. His design not only one house, but 300 different typologies. 300. And this is before computers. His office manually designed 300 different houses, ranging from 1 to 4 bedroom houses. All are able to actually expand, to change, to adapt to its users. an absolute marvel. To do this, a set of non-written rules were set up, and he used it innately, naturally, without even explaining. If you walk there today, this is what you will find. Some really contemporary-looking houses, even though they're almost 50 years old now. All different, all with different floor plans, with different facades, different openings, some of them with different materials, some of them have enlarged through time. So attractive still that with the advent of Airbnb, designers still rush there to actually rent it for short stays. So, the question lies on what connects Palladian villas 500 years ago, Frank Lloyd Wright prairie houses, and Melagera houses. Well, they're all houses, but all different, very different architects, different geographies, different centuries, different floor plans, different set of rules, very different budgets. What connects them? Well, when we put the structure of each design side by side, this is what we see. What connects them is the method. It's the set of unwritten rules that every single designer uses to attain their houses. And there are different methods. They all use different stages of design. They use different rules recursively and interactively. And they all allow for a broad range of different solutions. They're all extremely prolific. But when we compare what are the similarities, we understand that there are far more similarities that meets the eye. These are simple rules, simple geometric rules that every single architect uses. Adding a rectangle, splitting a rectangle, shifting an axis, basic subdivision rules that guide our designs. Some of us use them innately, without even noticing. Some of them use them with precision. I try to map out basically all of the different houses that you can attain by using those rules up to 5 different iterations of subdivisions. And in this large 400 corpus of houses, you will find some of the houses that I've already showed you, from Palladio, Siza, Wright. They're exactly in this corpus. A very minute proportion was the successful one, the one that tested time and it still endures and was actually conceived. What connects all of this? Basic rules, basic intentions, a will to design beautiful things that are functional, and not functional in this century, but functional in the long-lasting time. So the question that lies is, does beauty follow a code? Is there a set of rules that we can find and master to actually design more successfully? Well, at the University of East London, we believe that's probably the future. We believe that potentially we can develop a code that will allow us to rethink how housing is designed in the future. We all know that we're going through a global housing crisis, either because we are overpopulating our cities or because we are trying to sort of manage the climate emergency that we're all facing. And there's so many climate migrants and so many wars and conflicts that are being occurring. So we decided to create what you see here in this image, which is pretty much what it's called a shape grammar, a generative system, a design system that allows us to code beauty and design multiple variations that could be adaptable to different scenarios and could be tackling pretty much mass customization of housing. So what does this have in common with Wright and Siza and Palladio? Well, we're using the same rules, different proportions, different variables, different iterations of the rules, but nevertheless, a set of rules, a design system. And you can see here how this system moves from the very genesis to the end scenario. If we sort of map out the whole strategy of this design language, of this shape grammar, you can see here how step by step these rules are incremental. We start by a simple module, an entrance space. We move on to a living area, a dining, a kitchen, a bathroom, a bedroom. The rules are applied iteratively with different proportions and different variations, and sometimes allowing multiple variants to actually occur, allowing us some sort of diversity, which is what our famous architects also strive to achieve. And then, using current day's technology, we use 3D modeling and computer-generated imagery to assess the aesthetic quality of these houses. Also, we were really interested in knowing how different technologies can help us in this task. So we also used 3D printing to assess quickly the 3D quality of these houses. So what you see here is 3D printed houses, and particularly in terms of compact housing and emergency relief housing. Housing that needs to be built quickly in compact shapes and can be shipped or printed quickly. So to do so, we took one of these examples of compact housing, and we used 3D printing using clay. And clay allowed us to test cheaply and efficiently if our solutions were structurally feasible, if we had a good plan, if it would allow us to create an interesting solution. And then we went forward. We actually used robotics. We used an ABB robotic arm set up with a 3D printing concrete extruder nozzle to actually print this in real scale. So we printed a real size scale model of a specific wall of this compact housing. What you see here in the sequence took us about an hour to print. So imagine what we can do to actually print a whole house. A house like the ones that I've just showed you would take something like 48 hours to print, reducing costs, reducing material waste, reducing labor, using very scarce materials. So, does beauty follow a code? We believe it could. Thank you very much.